Go back to that for just a second. Okay, hi, this is Karen O'Brien with FLO-2D Software, and we're going to talk today about processing tools, processing programs for QGIS. Now, last week we did the QGIS tools. So basically all the tools in QGIS link to these processor programs in some way or another. So if you didn't get to see last week, you can come back and get the QGIS tools off the YouTube channel. And then let's just go ahead and get started on this. So let me pull up my notes. So we're going to talk about the MDAL tools, the MDAL drivers or libraries or processing tools or whatever you want to call them. They kind of go by the same thing. That's the mesh generation. And then the GDAL, which is just the geospatial tools that are, I think they were created by MIT, and they're open source libraries. GRASS, which is another geographical, it's an acronym for something. We'll figure it out when we get to the web page. ASCII text files, how to manage ASCII text files, and a little bit about Numpy because I'm really just getting started with Numpy. But I did want to show you that, I've got a Numpy script that was given to me by an engineer, so we'll talk about that too at the end. So let's start with MDAL. So a couple of weeks ago, 2 weeks ago, I did a presentation on streets and gutters, and I actually need to redo that presentation because my recording of it messed up. But at that time, I was having a hard time getting my MDAL libraries to read the data correctly. Anyway, so I figured out what was going on, and I sorted that out so I can show you that. So this is I think this is probably critical if you're doing FLO-2D modeling to be able to map it on the fly and in the same map as your data. So that's the cool thing about MDAL. So let's just give you an introduction to what MDAL is first. I should have it here. Or no, yeah, here we go, MDAL. So let's get here to the home page. So it's a mesh data abstraction library coded with C++, and it was developed, I think this is Lutra's tool. And what you get is drivers to help read data from all kinds of sources and to manipulate meshes. So you can see here that, HDF, HEC-RAS output, we got your FLO-2D output in here somewhere. There's a few other things, yeah, for FLO-2D outputs. And I think they have a 2-flow, something for 2-flow. So any of the kind of maybe even something for XP Swim, I'm not really sure, but any kind of modeling that you're doing, you might be able to use this MDAL library to get the results into QGIS, which is pretty cool. Now, if you ever have any issues with MDAL or you ever want to learn how to use it, you can probably contact Lutra directly through this. They probably have a community page or you can just get a hold of them directly through their website, and they can help you do things, or they can even help you develop things. So they're excellent developers. All right, so let's go back to this QGIS project and take a look at this, what we got. So clearly we have 2 meshes right here, but I just want to give you a little bit of information about these first. So the mesh generation system has evolved over time. So it has evolved in part because Noemi had actually changed some of the way that the data was set up in the HDF5 file. And so when Noemi made that change, Lutra added that update to the latest version of the MDAL libraries. So if you're using the latest version of QGIS, you have to also be using the latest engine. So if you are only getting maximum depths and maximum velocities and grid elevation depth on your map, and you're not getting the time variable data, you need to update FLOPro engine. And like I said, we're going to be releasing that probably, I'm hoping the end of July, but we should be releasing that. And if you need it in the meantime, just give me a holler because it's available on ShareFile. It's just that we haven't done an official release with all the documentation. Okay, so here's how you get access to MDAL for FLO-2D. And I'm assuming for any other project you may have, like it's going to recognize it. So if you had to add a mesh layer, you're just going to navigate. In FLO-2D, it's super easy. You're going to just navigate straight to the folder where the data exists, and you're just going to point to any one of these files. I typically just go with depth.out just because it's consistent, but it doesn't matter which one you point to because it's going to read everything in here that it needs. Now, what I want you to see from this is that we have two things in here. Well, we have the HDF5 output, and there should also be like a, yeah, net, I think this is like the net CDF HDF5 output. So there's two different HDF5 files in here that you can read. And so this is just time variable data. It will also read the maximum data. So it'll read from like the depth fp.out and the water surface, whatever the water surface file is. I think this is a max water surface file.out and the elevation. And it will give you, once you load it, so once you point to it and you click open, it's going to read it and it's going to say, hey, you want to load this layer, whatever. I'm not going to do that right now because I've already got them in here and I've got them the way that I want them to look. So once you get them in, you won't really see anything because it's the time variable data. Actually, like the first time you bring it in, you'll see the bed elevation. But if you want to take a look at it, you have to open this guy right here. Now this is your temporal management tool. And unfortunately, for whatever reason, I can't get this menu right here or this panel right here to drop down anymore. So we'll have to use the drag bar. Not sure why that is, but let's see. Let me see what would happen if we did that. Yeah, there we go. Okay, that's not too bad. And so now you can see that you have your temporal controller set up. Now, the first thing that you do when you get your temporal controller set up is you, I believe you just hit the refresh button or you hit this button right here, and that should adjust the range of time from, this one goes from 24 hours. So it goes from 21:06:04, which is the last time I loaded it, to 21:06:05. So because I loaded this during the last lesson or 2 lessons ago. And so it's 24 hours with a 30-minute increment. Now you can have a different increment. That's perfectly fine if you have different increments. And the time step in this case, you can also set that from, whatever time step you want to apply to that. Okay. And then when you play it, it will play the animation of the flooding, but that's kind of not really what we're interested in right now. What we're interested in is the view of it. So let's get this kind of up here and out of the way. And you can see that we get some depths in here. Now what I have is 2 different meshes, one with no storm drain and one with the storm drain. And I'm not going to put a whole lot of detail into this because this is an entirely different lesson, but I just want to show you a few things about this tool that are super duper handy. So first of all, if you want to make any changes to it, you have to have the styling panel open. So right click and you see here are your panels, and just make sure you have that layer styling panel checked. And then I always like to just dock all 3, the FLO-2D panel, the layer styling panel, and the processing toolbox on the same docking panel because I like to use them all together. And one of the things about it, the layer style, is that you do need to drag it over a little bit so you can access these. So now you can see that we can get access to the bed elevation, which is that's the original format the data comes in, this color scheme. The depth, and that is time dependent, or the maximum depth, and that was your maximum depth. Velocities, time dependent, that's the time dependent one, and maximum velocities, which I didn't recolor yet. And then the vectors. See how you can turn the vectors on and off super, super easy. And then I don't know if it can, yeah, maximum water level. Okay, so let's take a quick look at this. A couple things I want to show you about this that I didn't get to last time because it wasn't really working all that good. So let's turn off the velocity vectors for now, and let's put it back on the time-dependent depths so you can see how this fills up and shares. And you can see that I'm filling up this detention basin here, and it's not really sharing until it overtops the detention basin because my storm drains are not turned on. So if I came down here to the storm drain and showed you the same thing, let me turn the, hang on, with storm drain. Yeah, I just have to click it. Oh, sorry, to activate it, you have to click it. Then we come down here, just turn off the velocity vectors for a second and do the same thing here. And you can see that we're not getting that overtopping of this basin because my head wall is turned on and active and sharing between the two basins. So that's one way that you can use it to kind of make comparisons between the two, like without, you can see you can make your comparisons super easy and see changes in the water, and the time is the same for both layers. It's pretty sweet. So there is an entire video on how to set this up in YouTube, and it's still a valid video, but the only difference is if you want to get this to work, you need that 2020 engine, or that, yeah, build 20 engine. Or maybe you need to go back in time and get an older mesh MDAL and an older QGIS. I would probably also do it. And then you could, I believe if you had like 3.14 QGIS, you could probably read the build 19 data. But I haven't tested that yet. I'm just assuming it. Okay, so that is MDAL. Let's show you now. So that's temporal control, all that stuff. Close this out because now I want to show you the Crayfish part of the MDAL. Of course, you have export animations, export trace animations, things like that, which I'm not going to talk about that today. But we have this 2D plot that's super helpful. And if you grab this 2D plot, you can choose your layer. Let's just do with storm drain, and we will plot a time series, or you can plot a cross section, but we'll plot a time series, and the group will be depth, and from a map from a point, and then if you put your cursor on the map, you'll see your depth map displayed. And so you see here on the depth map, let's get into this, let's just get into this basin. You can see that we have, maybe 2-3 feet of depth on the when the storm drain is working, and when the no storm drain, time series, depth, point, then you can see we have up to 10 feet of depth because we didn't, this was blocked right here and the water wasn't flowing through to the second basin. And so it just gets up and the depth gets up and stays up. So there's no pulse of water coming in. It's just filling it and containing it. So that's I think that the mesh tool is pretty sweet, and the Crayfish plugin going along with the mesh tool works really good to show you what's going on locally in places. And I use it quite regularly with storm drain modeling because if I have something that I have water flooding somewhere and I'm like, well, why isn't that going into the storm drain? Then I can figure out right away, why is it not going into the storm drain? Because I can compare this map to what's happening in the SWIM EPA data, or the EPA SWIM GUI data, because you can plot a lot of things with the SWIM GUI too. Okay, that's basically it for MDAL. I don't have too much else to say about it. So now let's move on to GDAL. So Most of the GDAL tools that I'm going to show you are kind of already available through through these guys right here. Vector processing tools and vector analysis tools and raster processing and analysis tools. So you can see here that you can, all of the tools that I'm going to show you here are also in the processing toolbox. And I just want to kind of show you a little of these tools, but from here. So if you put in the word GDAL into the search, it'll take you straight to the GDAL library, and it starts out with a raster analysis, raster conversion, raster extraction, miscellaneous raster tools, like merging two rasters is a really good one. So you have all kinds of things that you can do on rasters and vectors with GDAL. I'm just going to show you a handful of them that are kind of fun to use. Because the bottom line is you're not going to know you need this tool until you need it. And so showing you all of them doesn't, or showing you like a lot of them doesn't make a whole lot of sense. But some of them are kind of fun. So this hillshade tool is kind of fun. You can take your elevation data and just drag and drop it straight into the input field. Or you can get data that's outside of QGIS. And then I'm going to give this a vertical exaggeration of 2:1 scale. And then I just think I'll just leave this one at 1. I don't really know what to do with that one anyway. I haven't really messed around with it too much. But the cool thing about this processing tool is that what it gives you is the command line of GDAL. And so then if you're interested in learning more about that specific procedure, you can look up the GDAL tools on the GDAL's wiki. And so we can just hillshade. Well, here we go, hillshade. And it gives you like a list of everything that you can apply, every command or argument that you can apply to this library or to this driver. And then if you need more information about it, you can like go to the hillshade layer or here, right here, and so you can find each individual command, I guess is what these are, or maybe argument, whatever, and you can figure out what it does and test it. So that's the kind of the fun thing about GDAL is that it identifies each one of these and shows you how to set them up, and it gives you some examples and some tutorials. So it's got some really nice data in it. But like I said, you don't really know you need it until you have to do like a internet search because you need to do something specific. So let's go ahead and click run on this. So here is, it tells you all the commands that we're using. And then we click run on it, and it will give us a progress bar of what it's doing. And then again, some more progress information here. And then it tells you that it's completed successfully, and it tells you where it put your output. So in this case, I put my output to temporary because I don't want to keep it. So if you, let's see, I'm going to see right somewhere out here will be an output option. Yeah, hillshade. That's the name of the layer, and you can save it to file or you can just put it to temporary. I typically usually start with temporary. And then if you find you like it or you want it, so then you see what you get is, let me make sure that this is on top, okay? What you get is just a raster with exaggerated vertical scale so you can see things better. And you can probably do the same thing by just modifying the symbology of here. Yeah, it's got a Z factor. You can do the exact same thing here. But what if you want to do that like to a batch of files or something? If you want to do it to a batch of files, then you can set this up in batch mode. or you can create a script, and the script will apply it to all the files that you want to address. Okay, so I'm gonna get rid of this because we don't need it. And I think I'll turn these two off for now. And okay, we'll just close that up and just continue on. Okay, so hill shade is good. I think roughness is fine. It just gives you like the roughness of based on the slope, but I don't know how to use it exactly, so I'm not going to go into it. Slope is kind of cool. Just gives you like, well, let me just do one, super easy. So just click, let's see, a ratio of vertical to horizontal. Let's just make that 2 and run it. So this will just give you a map where the white color is a steep slope and the darker colors are not steep slope. And you can see here that if you took, let me find it. Where did I put it? Slope. Okay. If you take the ID, you can kind of get an idea of the slope right in there, the slope of this. I don't typically use it like to do slope of channels, but it can do good to give you like the slope of a sidewall or maybe the slope of the sidewall of a channel. But I don't really like using it here. I don't think is probably appropriate to use it like to try to get the slope of the stream of a channel. We'll show that in a second. Okay. And again, we're finished with slope. And you see how easy it is to make these. You just load the data and it's already set up with instructions on how to do it. Let me remove this layer and I'll show you what I mean. Also, let me see, that's identify results. Okay. Oops, wrong one. Let me grab one more. Let's try the GDAL to XYZ, but I'm not going to do it on the elevation 1 because it has way too many points. But we can do it on the elevation interpolated because there's only 54,000 points. So GDAL to XYZ is just basically taking the band of this elevation data and saving it to an ASCII XYZ file. If you want comma separated values, you can check that. If you want space separated values, you do that. Sometimes you can put some extra information in here, like to give it an additional argument. For example, you see that that one is band 1, and then this one, then it might be like a space and then a dash tab or something like that would, maybe write it out as tab. And again, like I said, you can go into the GDAL to XYZ documentation and let's see if it GDAL to XYZ. Let's make sure that that's the right name. GDAL to XYZ. Wait, let's see the library. Let me just grab that off the library. And yeah, there we go. So if you need to set a, let's see, help. Let's do help. Yeah, here we go. Nice. And you have your arguments here and all of the additional commands that you can apply to that code. And they're all listed in here with instructions and a little bit of extra data. So let's see, elevation 1. No, we don't want that because that's too much data. And then save it to a temporary file and it should load it right to the map. So just run that and says that it finished. And so we close it and let's see, where did it go? Hang on. All right, let me try it again. Let's see, where is it going? Output.csv, processing output.csv. It didn't load it back to the map because it's just an output file. So let me try that again, but this time I'll save it to the desktop. And we'll call it elevation. And run. once it's finished, I'll open the file up so you can take a look at it. Oh, that's funny that I checked that button. Now I gave it a different argument. Let's see, elevation.csv desktop. Okay, let's see what we have on the desktop. Let's see if it's locked. It might be locked if it's still writing to it. Oh, it says locked for editing, read only. Yeah, so it's still writing to it. Let me make sure that, okay. So let's go back and we'll let it finish. And what does it say? It says permission denied. Yeah, because I was messing around with it. I shouldn't have opened it. Okay, let's see if it's open. I'll just open it in Notepad. And yeah, here it is. So this is just the pixel, the centroid of every pixel, X coordinate, Y coordinate, Z elevation. Okay, so I actually use that all the time. I don't know why, but I use this all the time. Okay, clip a raster by extent is another good one. If you have, like, for example, this original raster was, I don't know, several gigabytes of data, and really difficult to manage. Whenever you loaded it, it would take a long time to load. So I just clipped it to, well, basically you can see where I clipped it. I had a rectangle. I clipped it to the extent of the map. And you can see that right here. Yeah, there we go. So I clipped it to the extent of the map from the original raster. And I'm referring to this one right here, this elevation. Nope, not that one. This one right here, elevation, original elevation data. And I clipped it just to the extent of the map using this guy right here, clip a raster by extent. And so you can set the extent, and usually it's easiest to set the extent by a, let's see, clipped extent, input data. Somewhere in here, there's a, clipping extent right here. You can get it from, sorry, I didn't want to show that yet. You can get it from a layer, the map canvas, or you can draw a rectangle on the canvas. So the map canvas extent, and like typically what I'll do is I'll go by computational domain or grid. So for example, let me just do one by grid. You unfortunately you can't use the cursor or the keys in here to take you straight to the G's. You have to do it manually. And then let's just click run it. And it's finished. And here is my clipped by extent. Let's turn some things off so we can see it. Yeah. And you can see here, what, I don't know what I put in there. Oh yeah, it was elevation 1. Okay. Or maybe it was, might have been elevation 30. Okay, but anyway, super easy to do that and quite fun to use these tools. So you'll enjoy yourself when you're, testing these out and trying them out on things. There's also a lot of vector processing, like you can dissolve, where it takes anything that has like the similar attribute and it'll dissolve it into a single layer. You have to be careful with some of these because they'll create multi-polygon geometries, which then break other things. But they're still kind of fun. Now, I kind of use this more, I kind of use the GDAL tools more for rasters. And then if I need to do something to a vector layer, I'll just, pull it off of here instead of off of here. Now, let's delete that, because what I want to show you now is that everything, so as you can see, all of these guys right here are mostly the GDAL stuff. Most of this, standard tools, I guess we'll call them, are mostly going to GDALs. But you also have grass, GDAL, grass, saga. Yeah, those are kind of the main processors that you have for QGIS. And the funny thing about them is that they all kind of do a lot of the same things, but they do them slightly differently. So for example, if you wanted to use a raster clip, let's just say clip raster, and you wanted to use the Saga instead, you can see that it's a little bit different in how you pull it up. You clip it from a polygon only, not a map space, and you can actually click it to like a selected feature of that polygon. So that's kind of cool too. So they all do exactly the same thing, but they do it slightly different. Okay, now let's move on to let's talk a little bit about grass. Now, the only reason I really wanted to talk about grass is because it has a couple of things that are kind of fun, but also I wanted to mention that if you want to use grass, you have to install the version that is with grass, because it's kind of an independent program. So what you can see here is that when you pull up QGIS, you have like a lot of different options. First of all, it's going to show you any QGIS version that you have installed on your computer, but it's also going to give you, like, if you set up your computer to always run just the main desktop version, that doesn't have grass, so you can't call these libraries. So if you need grass for something special, and I definitely use it occasionally for minor things, because it has a specific way of processing the data that works good for what I'm trying to do. So you have to make sure you load the one with grass. Okay. And of course, you'll know that you did that, I think, because you'll see these guys right here. Okay, so let me see. Now, mostly grass works with imagery. So like if you're trying to do some geo data on aerials to like identify a land use category, or to identify vegetation, or maybe to identify like paved surfaces, then grass has some really nice image tools that will help you with that. Grass also has some LiDAR manipulation tools. So if you have some LiDAR data, there's some LiDAR libraries or some LiDAR processors in here. But we're going to show you just something kind of fun, just to show you how they work. So let me see, what I was looking for is this guy right here. This one's just fun. So I like this little tool because it gives me a way to kind of fill something. And it's easy and quick. It's super fast to use. So let's start with our satellite. And you see here that we have this basin. And what we'll do is we'll use this tool to fill this basin. And I've already done it. You can see it here. I've already filled the basin, but here is what the basin looks like. Hang on, not that one. Sorry. Here is what the basin looks like before it's filled. And again, remember, if you had that hillshade and you added a Z factor of 2, you might be able to see that basin a little better. All right, now let's go ahead and just run the process. And it already picked up the right one because that was the active layer. And then we give it a water level of 1388. And let me show you why I chose 1388. Let's keep on this guy. And if you get around here, the rim elevation of this basin is 1390 at kind of like the lowest point. And so I can, let me grab the processing tool again. I just put in here 1388 or 89 or whatever. You don't want to 1389. And then it says select a point to fill it. So I think for this one, I just hit that button and then I select the point, and that seeds the location where it starts to the fill from. And then I don't have this. I don't have this data, so I'm not going to bother with that. And then I just click run, and it starts its processing. And don't worry about this map set locking. It comes up on a lot of these, and that's fine. You just ignore it. And then it should have finished. And again, I'm not concerned about that error either. And then you get your lake.tif, and then close it. And it also tells you where that file is stored. If you want to go copy that or something, you can you can copy that path and go get that, or you can just save it. Okay, and then what you get is, yeah, here, let's just remove this one. What you get is this little raster filled up to 1388 feet, or filled up to 1388 feet. So to basically fill that basin, super easy. And then you can take another processing tool. Let's see if I can remember how to do this. Zonal statistics. We'll try this one in a minute. Let's try that one in a sec. Yeah, zonal statistics. That's the one I'm looking for. So I'm going to remove that so we can run it again. And we are on this guy, and we type in here zonal, and it brings up a lot of different kinds of zonal statistics. And I recommend you just try all of them because they all work slightly differently and give you slightly different information. Well, let's try this one. And so we're only applying it to lake. The zones layer, I don't have a zones layer. So I wonder, let me try a different one that doesn't require zones. Let's just do this one. There we go. Input layer is maybe, I don't think I need that because it doesn't, it's just the small, tiny little section. But if you wanted to clip your zonal statistics to something, you would do it with this guy. But I don't. Okay, so here's the lake, and I'll just click run. I don't need anything special here, just click run. Oh, well, maybe I lied about that. All right, so let's try a different one. Not that one. Let's try this one. It's aspect. We'll see how this works. I'm kind of forgetting the one that I used yesterday is all. Or you know what, I think I can do one other thing though, is I actually have a raster layer, so I can do that. Yeah, here we go, perfect. All right, so I used the, let's see, what did I use? I used the Saga one. And so I wasn't required to mask it in any way. And then if you open it up, it gives you, well, you have to go figure out what these statistics are, but basically it'll be like the count and maybe max, min, things like that. Could give you a histogram of it. So unfortunately, it didn't really work. Well, didn't really show you what I wanted to show you. So instead, because I didn't really use it very well, but instead, let's do this. Let's take a quick look at the properties of this, and we can look at the histogram. Sorry, let's set the band. No data value. Oh, you know what? Yeah, that's why it's not working, because we're not doing a very good job of, this data isn't elevation anymore, as you can see. It's just a fill depth. That's why I was confused. Okay, so I did the zonal statistics on the wrong layer. So let's try that again. So here I have a polygon that can mask the layer, and I have the layer I want to review, and we should be able to just run this one here, or this one, and we get the elevation 1, No, still have to have the zones. Yeah, that's fine. This one is rain ARF areas, I believe, and click run. And then it calculates the zonal statistics of the elevation data within that thing. So where did it put it? Output zones. Okay, let me close that and right click on that and open attribute table. Uh-oh, that's a big one. Okay, I might have messed up by opening that attribute table because that's still a 1 foot raster, so it's a huge amount of data. No, that shouldn't have taken that long. It's only oh, wait for it. It's only a single polygon. It's only one feature, so it shouldn't have taken that long. It's gonna, can I quit? Can I cancel this without losing too much data? I think I can. Yeah, let me just do it. All right, we'll get it right back. Oh, sorry, questions. Yeah, you can, Werner, you can make a video of that water flowing. So you do need Crayfish for that. So make sure you install the Crayfish plugin and then go watch the video because that's where I show you how to make the video. Okay, let me grab this right back. I might have to add that lake layer back because I think I probably lost it. And we're gonna need it for the volume analysis. And let's put these guys back in here. Okay. Oh no, I got it. Excellent. It gave it back to me. That's nice. Okay, so let's remove this one. So I'm gonna skip the zonal statistics for now because for whatever reason I've spaced out how to do it. So I did it yesterday, but I'm apparently not capable of doing it today. So let's do this instead. Let's move on to, let's see, volume. Okay, so here we have a raster volume. So GDAL, grass, or saga. And again, I just recommend you open each of them, base level 1388, and just see how they work. Method, add volumes below the base level. And we can save it to a temporary file and run it. And then just see here where it comes out at is a report. Okay, so where did the report go? Output file.html. Let's see if we can copy this, copy, and your report is here. So you get your volume, and this should be in the map. Yeah, this is square feet, so this will be cubic feet. And so then you can convert that, using whatever converter you want. So again, that one's super easy. So if I took this clipped raster of this lake and I wanted to calculate the volume, I just put in here volume. Now, if you look at a few of the others, they're all basically the same. I was hoping there was a masking layer, lake, band, base level, method, report. Yeah, they're all the same. There's not like a masking layer. And algorithm cannot be run. Oh, I didn't open it back with grass. That's too bad. Okay. See what I mean? You have to open grass, so that was that was unfortunate. Well, anyway, let's grab that. Let's see if we can grab that path and pop it in here. It only gave me part of it. That's too bad. Let's see. Yeah. Okay. Well, anyway, make it as an HTML file. So as soon as you open it, it opens right into your web browser, your default web browser, and gives you the information you need. Or sometimes it'll put it in here too, but it didn't this time. Sometimes it'll put a little report right here. Okay, let me go back to here. Grass, ASCII text files, and Numpy. All right. So we're pretty much done with some of these libraries. Let's get rid of this. And let's talk a little bit about FLO-2D data, because FLO-2D data is always ASCII data, right? So every time you do a project, let me see what I got here. I've got advanced class, module 8. This is one I've been working on. Or did I get module 9? Let me open this Python console for a second so I can see where my data is. Okay, here's my data. It's oh, it's in the debug module, infill.dat in the debug module. Okay. Okay, so let me go to the debug module. And okay, so now we're sorted by type. And what we have is a series of ASCII data files. So if you open this up, you can see that it's all text data. That's all FLO-2D.dat, and all FLO-2D results are text data. And they're all written in columns. So ASCII text data, space delimited, can be sorted quickly into arrays without having to load the data into QGIS. So let's just show you something here that you can do. First we'll do this with QGIS, Excel, anything. You can import and review data in any way. So let's just do this one. How about we get the rain.dat, or better yet, let's do the swim. Let's do the swimflow.dat, and I Control A and copy that data, and then I'll pop open a new Excel spreadsheet and paste the data in here. Ah, crap. Sorry about that. Not that one. Good grief. Okay, and then so in order to manipulate it or review it or max mill, whatever you want to do that, you can click data and then text columns, and it's space delimited. So you just put a space in here and treat consecutive delimiters as one and finish. And now you have your FLO-2D data in Excel, and you can come in here and sort it max to min, or you can do math on it, any kind of Excel function you can come up with. And then in order to put it, like if you want to do something to it here and you don't want to load it, or bottom line is you can do your math here, you can do your editing here, or you can do your editing in QGIS. So you have the opportunity to look at the data in Excel, which is super easy, and everyone knows how to use Excel, so that's good. Or you can use the, let's see. Attribute editor, which we saw in the last class on how to use the attribute editor. And it also has its own calculators and things that you can apply calculations and scripts and things to. But what if you have 2 million of cells or 2 million storm drains, or well, you're not gonna have 2 million storm drains, that's ridiculous. But what if you have like 2 million infiltration nodes and you have a problem with one of them, but you can't quite tell what it is because the error message you're getting from FLO-2D is not elaborating a grid element number. So in that case, we have the Numpy. So let's first off bring in bring that data into well, it's already in here. Let's take a quick look at this infiltration file. This infiltration layer right here. Infiltration tables, infiltration layers. So you see what you get for infiltration layers is a single polygon for each cell, and that has a single value. So if I open this attribute table, hang on, sorry, green amped. Open the attribute table here. It's 54,000 cells. It takes seconds to open. But if you have 500,000 cells, 2 million cells, 3 million cells, something like that, it's going to take a long time to load this data. And then anything that you want to do to this data is going to take even more time. It's like if you want to sort it, you're going to be waiting for that data to sort. So instead, you can, let's just sort by hydraulic conductivity, 0.01, 0.42. So instead, you can apply a Numpy script to any of these data files, and it will do this for you. Now, I am going to give a shout out to Stantec, because Amelia, I think it's Oxpenshine, I don't know if her name is pronounced her name correctly. I think it's sorry, Amelia, I can't pronounce your name. But anyway, this data is, she gave me this script, and then I tootled around with it to, make it read different columns. And so she started out with RTemp. She was trying to find something with a problem she was having with RTemp. But then we found out the problem wasn't even in the infil.dat file. So, but we were able to use her script to quickly review the infiltration data on her project without having to load it into a text file or Excel or anything like that, because it was too big to load anywhere and there was no need to load it. So you can do this with the command prompt, or you can do it with in this case, the Python console, the QGIS Python console. And she gave me this little script, and I'm just going to show you how it works. So basically, we're going to use NumPy, so you have to import NumPy library or module. We call that a Python module. And then we're going to make, if it imported correctly, it'll do finished importing. If it doesn't import correctly, it might not show you anything. And then we're going to define the location of the infiltration.dat file, which is right here on my computer in the debug folder. And then this class, this little script right here, will load the data into an array. So, well, first of all, it's going to create the array, create the array variable, and then load the file as a read only, and then read the lines of the file, and then close the file. And now the data is in the memory of the computer. And then for every line that it reads, it's going to strip out all the spaces or commas or tabs or anything that's separating the data, and it's going to assign the data to the arrays. So then you see here that the data from those lines has, I think, like 8 positions. Let's open it and see. Yeah, it has, let's see, 0, 1, 2, 3, 4, 5, 6, 7. So it has 7 columns in the array, and it's going to ignore anything that doesn't have an F, because that's what the code told it to do. And it's going to load the rest of this into the array. Okay, so see here, if the value has an F, then a hydraulic conductivity is column 0, 0, 1, 2 is column number 3. I hope I have this right. So this is column 0, column 1, column 2. So this is or index position, and this is the hydraulic conductivity. And then for NumPy, you have all these excellent simple commands you can apply, such as the max, the min, or sort the data. And so if you want to get the maximum of this array, you just add that as an argument to this command. So maximum equals numpy.amax, and then apply that to the array, and then print maximum. So if you click play, it'll print 0.42, which is exactly what we got from the table, which maybe I still have open. Nope. Did I do that right? All right, there we go. And again, if we sorted that, you can see that the max and the mins are right there. And you can quickly change the column just by changing this number. So if you wanted to apply to our temp is 6. Now, of course, the variables can also be renamed, and then you can save that into a secondary script and say, you know, this is sorting. This will sort, this one will sort, this one will find the max, this one will find the min, this one's applied for infiltration, you know, whatever. You can have as many of these as you want. And you just keep them all in the same spot on your computer. In my case, I'm just putting them all in the C drive for under this Python script file folder. And then it's ready to go. So that's NumPy, and it's 12:30 on the dot. So that turns out to be perfect. So if you want to try this out, I know that I have a whole range of viewers. You know, I have viewers that can build these plugins, and I have viewers that have never opened QGIS. So I have the range of people who I'm trying to address. So if you guys want information like this, you know, the hardest thing about getting and building a little sort routine like this is like just getting past that first step. Like this little guy right here is basically the hardest part, is getting this to work correctly. And then if you can get this to work correctly, the rest of it kind of, you know, you can apply tutorials and you can do all kinds of testing and training to show you how to build these little modules. So I'm going to stop recording.